Can go home. All right, we are going to now move away from that for a while, that being meters and Ohm's law and things like that. We'll see how many minutes we can go without Ohm's law. And we are going to go with what I actually was calling symbols. And wiring is what we're going to go to. So a lot of this will probably review for you, and as you've already found out, there are many different symbols. So I may do something a little bit different than what you've seen. I tend to go a little bit older in convention, and I like to find things that are representative of what I'm working on. It helps me out. So let's just start with a conductor, which is a train, which is nothing more than a wire. Well, that's not a hard one because it's just a line, right? But where it changes is, and you're going to love this, this is the older convention. Oh, well, older convention. If you have two wires in the older convention, this is connected. That means those two wires are connected to each other. C-O-N-N-E-C-T, connected. But if you don't want them connected, then what you're going to do is you're going to do something like this. There. That's the older convention. That is connected, not connected. And that's how you would show wires in that fashion. But now if you look at the newer convention, then this is not connected. Okay, notice the similarity between not connected and connected. Not connected, connected. What is the difference?
Well, the left one is on top. And the other one.
Yeah. And the this way is connected. That is connected.
When did they change that?
I don't remember. So how do you know which convention you're working with if you just see this one right here?
Dot.
You don't know. You have no idea. You would have to look around and you have to look for, does it have a loop or does it have a dot? And then once you identify the loop or the dot, you can go, now I know which one I'm working with. So if you have this loop here, then obviously that would be connected. So you have to put them together. I would say don't mix this one and this one. Don't mix those two.
So is the older convention not really accepted anymore?
Accepted by me.
Yeah.
I don't care which one you use. Until like 15 seconds ago, I couldn't have told you which one was new and which one was old. I don't remember that stuff. It's just how I like to do the older convention. I don't know.
It looks a lot more like, it looks like it makes a lot more sense.
It does. I can see this little loop a little easier.
Yeah.
It sticks out to me, and so I like
This
that.
is like,
Dot.
Yeah.
hey, this is jumping over versus not connected. It's like, okay, this looks like connected on the old convention too.
Yeah.
So like in the field, like the schematics that you'd be looking at,
Yeah.
they're gonna have this newer convention.
Not if it's an old plane, it won't.
Not if it's an old plane, but on like the new planes that are coming out.
Probably. Just have to know. It's one or the other.
The engineer.
That's up to how they drew it. You've already messed a little bit with shielded wires. Shielded wires, a regular wire that has the plastic, actually, and our wires do not have plastic coating on it. Like this has a plastic insulator. Aircraft wires are not plastic insulators, they're Teflon. They are strong, it is strong stuff. It is hard to strip, it is really tough, and they're usually white. But shielded wire has the inner core, it has the Teflon coating or plastic. Over top of it, it has what?
More wire.
More wire, like a stainless steel wire. And sometimes on top of that, it has
Another insulator.
another clear insulator so you can see the steel braiding. And what is the purpose of shielded wires?
Isn't that mostly used for communications to prevent electromagnetic interference?
Which what he said, but you said it like that fast. He said block EMF. And so that was the translation back there. So it is to block radio noise.
like knock sensors too, right?
Yeah,
Knock sensors?
like in a car.
Yeah, like in a car.
Well,
I didn't
no.
know they did that.
Yeah, I'm dealing with that right now.
Oh, okay.
They shielded it and it's a pain in the ass.
Okay.
Well, I have a question about the
yeah.
shield wire. So the outside shield, you ground it. Does it matter what side you ground or anything like that? Because
Yeah, I was just going to get into that. So, for many years, and shielded, they represent it like this. That's the shielding on it. For years, I had actually said, oh, well, what you do is you're actually going to ground out both sides. And then I found out somewhat recently, oh, don't do that anymore.
that's what I heard too.
Yeah. There's this thing called a ground loop. Now, ground loops in aviation have two very distinct meanings. One is what happens to a tail-wheeled airplane when you crash on the ground. And the tail comes around and the wing goes down and you smash up the wing. That's called a ground loop. That's what they call it. But in aviation or electronics, a ground loop is when you actually start to create another circuit through the grounds that has current start to flow through it in a weird way. Do you understand it?
Yeah, it's a big thing in audio, and
Yeah.
usually what you do in these, they have a special circuit with a ground lift. So if you get a ground loop, you can completely disconnect one side of the circuit.
Okay. So yeah, I've been told now, don't ground both ends for sure. One end should be open and the other end is grounded.
But so I guess then it would just be like ground whatever end is easier to ground because
What do you think?
So you want to ground one of the ends. You wouldn't ground it in the middle. What you're trying
Right,
to do is whatever EMF is coming in, it's going to travel down your wire, and it's going to be grounded out. If you connect it to both ends, it doesn't balance properly, and some of your EMF interference then is going to start to build and build and build.
and you'll get interference.
Exactly. You start to
So-
cause more.
I
So
got
you get a
question.
whine in your headsets and things don't work well.
So in the push to talk button in the sticks and the Luscombe, there's a tiny little hole, like just big enough for like a
Yeah, it's
shielded-
tiny little switches.
Yeah, and so obviously I think I can't run another wire from switch out there, a ground wire, so I probably have to ground to the other side, from the other side, right? Does it make sense? So push to talk switch is going all the way back to the back of radio.
Yeah.
So I ground, but the thing is the wiring harness on that thing came with wires coming off of, the plug that are just regular wires.
Mhm.
And then they say they're labeled push to talk, pilot push to talk,
Yeah.
but they're not shielded.
No.
So then do I just attach them to shielded wires and have half
No,
the
no.
wire?
You wouldn't. You don't shield the push to talk buttons.
What?
They're not shielded.
It's just a switch.
So, all
Where do
right.
you
So,
shield
where
them?
would I find shielded wires? Like on my aircraft, the only shielded wire I have is two. I have two wires, and they come off the magnetos. The magneto creates the spark for the engine, and we're talking about. It's coming out of the primary, so it's I don't know, is it 1,000 volts there on the primary? So it's a lot of voltage, and that wire comes from the magneto back to the switch, and when the switch is in the off position, it sends a ground. When the switch is on, the ground is off. So now I just have a wire that's yay long going from this high frequency generator making sparks into my cockpit, not grounded. It's open. So they put a shield wire around it because it is constantly pulsing, and that shield wire goes around it, and then out at the magneto, it's grounded. So it's going to take those impulses, go into the shield, and go back outside and ground to the magneto.
Oh, I swear I read in the manual that it was supposed to be a shielded wire. I'll find
My
it.
push to talks are absolutely not shielded.
Huh.
The
And
only
there was
wires you would want shielded in your audio system or communication equipment is going to be stuff that's hooked up to a microphone, a transmitter or receiver, and then your speaker wires.
Obviously, coax cables are shielded.
Yeah,
But
I gotta look.
So
at
like
what I
the
see now.
cables leading from like your VOR antenna to
they're coax.
their coax.
Mhm.
Yeah.
And they use in some of those applications, the shielding is used for just shielding, and some of them, the applications uses a second wire. Like we're just scratching the surface on this stuff. I mean, we get into, balun cables and loops and stuff, and it gets kind of crazy.
So like you push to talk, it's just a switch.
Yeah.
So
Yeah, I know. I just for some reason I don't know why there was a second radio that I was doing for my brother as well. That is.
All right, resistors. Oh man, we've dealt with resistors enough. That is what kind of resistor? Fixed. Fixed resistor. We have adjustables. Adjustable. Under the adjustables, one of them is a rheostat. R-H-E-O-S-T-A-T. Rheostat. Let me see. Used to vary current. Used to vary current. It is a two-pin connector, I guess. So it's connector, variable. Oh. Let's see here. Oh, we're not doing that. There we go. Rheostat. I just showed you right there. And potentiometer. They're often confused. So rheostat has the two connectors, as where a potentiometer uses three terminals. 1, 2, kind of 3, if you will, or a tap off of that. So we don't really get into center taps or anything. But so potentiometer, oops, wait a minute, 3 terminal. All right, go back to this. Rheostat. There we go. So we'll do this one. We'll say potentiometer. Potentiometer is a 3-terminal device. Used to control current. Used to vary current. Voltage. Because it's used in parallel. Used in parallel. And so I like this one here. Like that. 1, 2, 3. 3 pins. So what you would do is you would tap off of this one right here if you wanted a different voltage. So potentiometer versus rheostat. Rheostat is simply I'm going to go to the picture. There we go. A rheostat is simply a variable resistor, variable resistance used to control power to a load. The correct term for the common terminal of the potentiometer is a slider. Only the slider and one other terminal are used. Potentiometer uses all 3 terminals, enabling a variable voltage or signal to be tapped off from the slider. I know our books, the reason why I bring this up is our books have like so many different versions of these things. And so like I said, I distill it down to these 2 points. Rheostat uses 2 terminals, potentiometer uses 3. And when I bring it down to that, I'm like, okay, I get that. Potentiometer, they're usually pretty beefy. That little thing right there is rather large. And like my airplane, I think has 1 or 2 of them in there for controlling the intensity of the lights, interior lights of the cockpit.
So how does a rheostat vary its resistance?
Physically, how does it do it? I think schematically, it would make more sense to be like this with 2 pins. And this one is not pinned to anything.
Yeah.
So that way is less resistance, because if we got to right here, there'd be no resistance, right? And this way is more resistance because we have more of the resistor.
A scaling.
Yeah, scaling. And so that's how I would look at it that way. And the same thing with the potentiometer. If we go this way, it's going to be well, you'd be not dropping it, so it'd be more voltage. And going this way would be more resistance, so less voltage.
So potentiometer's voltage, rheostat is just resistance.
Yes, because this one is in series. See, it's got to go in series.
Yeah.
So series goes to this way and out that way, series. And this one goes that way and that way. So that is in parallel. So parallel means voltage, and series means amps, current. Everything just distills down to the simplest of simple.
What
So
would
what
a
you,
potentiometer be used for versus a rheostat? then?
I'm not an engineer. I don't design these things.
Well, potentiometer, like you just said, for your
Lights,
so
yeah, potentiometer lights,
Do you have
because you want to dim the
rheostats in your
voltage.
aircraft?
What?
Do you have any rheostats in your aircraft?
2? Oh, rheostats? No, not that I'm aware of.
Okay. Rheostats fake.
They're not real. They're like birds. They're not real.
Just the government throwing them in everyone's airplanes.
Let me see, 15, 16. All right, circuit protection. Circuit protection.
Love
Rule number 1. The circuit protection is there to protect the wire. Used to protect the wire. You have a $18,000 Garmin 750 with a circuit breaker that says, I don't know, it could be 2 amps probably. That 2 amp circuit breaker is there to protect
the wires.
50 cents worth of wire. That's what it's there for. It is not there to protect the device. So we have several different things. Fuse. We have the fuse. Most of you know all about fuses. They are expendable. So once they blow, you have to replace them. There's an FAR. Oh, I can't remember what it is. If you have fuses in your aircraft, you have to carry. It's not 1 of every kind. I want to say it's like 2 of every single possibility you have. I can't remember the exact number. I want to say 5, but that could be.
More the merrier.
Yeah, I don't remember offhand what there's an FAR. So get rid of your fuses and put in a circuit breaker is the fun part. There's current limiters. I'll just do this. Current limiter. I have a long note here. Current limiter, such as used in the armature circuit of a high current DC generator, is a form of a slow blow fuse. We'll call it slow blow fuse. That will accept a surge of current greater than the generator rating. But if there is a continual flow of current in excess of the rating, it will open the armature circuit and remove the generator from the system. They are normally cannot be replaced in flight. It's a mechanic has to do it. You got to get in there, and it's a piece of wire that melts out. And I haven't seen one on an aircraft. I had one on my truck. All right, circuit breakers. CIRCUI, circuit breaker. Circuit breakers. All right. Let's see. So according to FAR 23.1357 Charlie 1, hopefully it's still there because they have changed a lot in 23, requires that, EQUI, requires that circuit breakers, I'm going to put CB, circuit breakers not be automatically reset. The resetting must be done by the
Pilot.
pilot. So a circuit breaker, as some of you are seeing in lab now, well, they come in two different types, really. Type 1 has a little collar where you can pull and pop them out. Type 2, they're flush, and you can't pick them out. And they'll pop on their own, and you can push it in, but you can't pull it. I don't like those. I like the kind where, as a pilot, if I need to shut something down, I can reach over, pop it right out. No, I've got my aircraft, the autopilot with auto trim, which has had problems with runaway, nose over. I know exactly which circuit breaker by feel is right there in front of me. It's the one, there's a flush, pop. It's the first one there. Pop that one and the next one, I'm good. So I like to be able to pull those.
It was 23.1357?
Yeah, Charlie 1. So you can't have an automatic reset. Automatic reset would be it pops on its own and it's somehow spring loaded that after it cools down it'll pop back in, because there's different types of circuit breakers, how they work. Some of them work off of bimetallic. When they get hot enough, they snap and it'll pop out. And so when it cools, you could, in theory, the bimetallic metal inside would pop it back in. You can't have that. You have to manually push it back in. So
You have to acknowledge the issue.
obviously, to me, the obvious reason is you're flying along, you get a short. Some of you are still confused what a short is. A short means you're bypassing the load and you're going straight to ground. So you have a battery, a wire, and it goes right back to the battery. That makes the wire very melty and hot and smoky. And so you don't want that. So let's just say you've got a wire, and the wire has positive on it. And what's negative? The whole airframe. And so you have a wire that's rubbing on the airframe, makes a bare spot, touches the aluminum. Now you've got it from the battery right to here. That's a short. Okay.
What's
So,
past all it?
huh?
What's past all the current through it?
It passes all the current through it. The wire starts to melt, get hot. Circuit breaker pops. You're like, I smell smoke. You hear a pop. You're like, ooh, yeah, that was like a nav light or something. Yeah, okay, I don't want that. And so, if you're that kind of pilot, you're like, let's see what happens. You push it back in, it should pop out immediately. And then at that point, go, I'm not doing that anymore. But if it's automatically reset, we'll say every 5 minutes, it pushes itself back in. This gets hot again, smoke again. You can get a fire. So you don't want that.
With that in mind, you could also use that kind of diagnose what the issue is right away. It's like, okay, there's something.
Yeah, you just when it's on the ground, just keep pushing it in until the flame becomes obvious.
Well, no. You can tell where you. It narrows down the troubleshooting. It narrows down the troubleshooting.
Well, it tells you what circuit it is for sure. Yeah. Let's see. Circuit breakers. This to me is a circuit breaker that the kind you can't pop, you can't pull out, and this is the type that you can grab and yank out. Don't use it. It's not a switch. Not a switch. You can get in trouble if you were to wire this in as a switch. In other words, I've got my nav lights. I don't want to use a little switch. I mean, you got a circuit breaker and then a switch. Let's just cut out the middleman. Just make this the switch. It pulls, push back in. Can't do that. It wears them out too fast. So obviously they're connected in series. They are resettable. There is 3 types. 3 types. There is the push to reset. Push to reset. That's all you can do is push it in. There's the push pull. You can pull it or you can push it. If you pull it, what happens?
It goes off.
Off. And if you push it in, it's
Reset.
reset, not a switch. Then there is the toggle type, which is a switch. It's a switch / circuit breaker in one. And what it looks like is a switch. It's just at the end of the switch, little switchy part, right on the very end will be a number, and that's the amps. And that's how you know that's a circuit breaker switch.
And generally you see that on the sides of houses, right?
I've seen my airplanes.
Oh, you've seen one.
Do I have one on mine? I don't think so. Maybe it was my last plane. I had one in there.
Would that just be for like aesthetics or like space or something like that?
Space, yeah, something
More
like that.
space?
Yeah.
Is it ever like doesn't really matter whether you use those or you use push pull or push reset or
I
something like
don't
that?
think,
Just
unless it depends on what an STC. If you're home built, no, it doesn't matter. You can use
Whatever you
anything.
like.
Yeah, whatever you like. But I just go with whatever an STC says. I tend to want to split it. Yes,
So a circuit breaker is not a switch unless it is.
exactly. You can't use the push-pull ones as switches, but the
Don't
toggle
use it
type,
as a switch.
which I don't see very often, you can use as a switch. Let's see, different types. I don't think we need to go into this. I'll tell you about it, but I'm not going to write it all down. I will tell you this right here, that just remember, it looks like this. You have the bus bar, and the circuit breakers are literally screwed to the bus bar. There's no wire and then circuit breaker. It is piece of metal, circuit breaker. And then, if anything, there's usually the wire and then the switch going out.
So the ones that you have in your cockpit, that means there's pretty much a bus bar inside the cockpit. Okay.
Mm-hmm. All Cessnas have that. Most all planes.
So versus like inside.
It's a
the-
bare piece of metal. You can actually, if you're flying, stick your hand up around, touch it if you want. I wouldn't, but
Versus like the bus
Yeah,
bar
would
being
be-
in the engine compartment.
no, it's right underneath the instrument panel down low. Which you have to be careful because when you're working on stuff, sometimes you work on instruments or something. These switches, these screws are really. It's hard to get. You drop a screw, you got to freaking find it because guess where it is? It's sitting right here on this bus bar. Got a metal screw bouncing around on a bare piece of aluminum with power running through it. That is not a good thing to have happen.
Worst thing you can do when you drop something is swear, because then you're not listening to it as it's falling all the way down.
Do you know how many times I've actually just spent so much time looking for something? And when we drop screws, nuts, bolts in aircraft, it's not an option to go, oh, let's get another one. You have to find it. And sometimes it can take you a long time. And it's like this was a 1 hour job and you just spent 30 minutes looking for a screw that you dropped. That's not a good time.
Those little
Um,
extendable magnets are nice.
That's
But yeah, I've actually taken screws. I've had to go get a replacement screw, go in right, and drop it, and bing, and there,
Ends up.
right there. There's the other one. I've done 100 times. Okay, I'm not going to rattle this down, but in circuit breakers, I have 3 different types. There's the magnetic type. When excessive current flows in the circuit, it creates an electromagnetic force strong enough to move a small armature which trips the breaker. So if you think about it, well, that makes sense. If we have a circuit breaker that's 5 amps, when it gets to, let's say, 5.5 amps flowing through a coil, it will create a magnetic force strong enough to pop the breaker. That's how it's designed. We have the thermal overload. This consists of a bimetallic strip. That's 2 pieces of different kind of metal. God, I got some at home that really cool. When you heat it up, you can see it bend. Because one piece of metal expands at a different rate, it will do that when it's heated. So, which when it becomes overheated from excessive current, bends away from a catch on the switch lever and permits the switch to trip. Then there's the trip-free circuit breaker, which will allow the circuit to be broken even if the pilot holds the button in, which pilots have been known to do. So in other words, the circuit breaker keeps tripping. Well, you know what? I will just push and hold it in.
Cigarette lighter.
Yes. So that would be a trip-free. You can't do that. Aircraft do not use automatic resettable circuit breakers. They must be manually reset. Okay, switches. Let me see. God, we've already done all the switches. Yes.
Is there like a specification for like the sensitivity for the circuit breakers? Like, it's like you said 5 amp circuit breaker, and then like 5. You'll let it get to 5.5 amps and then break.
Oh, what is it exactly?
Yeah,
I don't
like-
know the exact mil spec and how they've done it. What the there's gonna be different numbers. Like some of them will go right away, just like fuses. Some are slow, but it can go over for a small period of time. You have the thermal ones. There's all different kinds.
I made it.
Yeah, it's why you have to be careful. Which you can't just go pick whatever you want. You got to kind of
Yeah.
so switches. Switches. All right, the thing I hate about this is we have the pull and we have the throw. Which one of these is an action moving thing? Pull or throw? To me, a pull is a stationary object that does not move, and the throw is an action, something that is movable. That's what I would think. And then I think about that, and I say, okay, that makes sense to me. Now just invert it. So the pull is the movable blade.
Lever.
And the throw is the number of paths.
Isn't it like switching Greenland and Iceland?
Yes.
Yeah, but that was like strategic.
And so if we did this, this is a single pole because it has one movable blade, and it is a single throw. It has only one path. Let me see. That is a
Single pull, double.
how many movable paths? Movable blades.
One.
Single pole. How many paths now? Why didn't they just call it single blade double path? Oh, that would have been so much easier. All right, and then of course the let's see.
Double pull.
And then you have to do this to indicate that those move together. So how many blades? So double blade, double pole, how many throws, how many paths per each one? So it's not a Q, it's not a quad, so it's double throw, 2 paths. All right. Let me see. Then I need to write, let me see. Switches are installed. So that on is forward or up. So you never have to guess in an airplane. If a switch is installed vertically, that is on. That is
On.
that is
On.
Yep. All right, battery. We've covered battery. Well, never know. All right, battery. Like I said before, that's a single cell. Technically, this is a multi-cell. Sometimes you may see something go crazy like that. Back in my day, when I first started, that was each one of these equals 2 volts. So if you had a 24-volt battery, you had to do 12 of those. All right, what is this symbol right here?
Ground.
What is a ground?
The negative terminal of the battery or to the airframe.
Yes.
The path back to battery.
Go ahead, you tell us, Cooper. What is a
It's the path back to.
is a
Complete the
path
circuit.
back to the battery? So if I did, something like this, here's my load and like that, is this just like maybe a piece of metal out here? And this is like if I had a fabric airplane, I just put, I'll just put a little square of metal over here and a little square of metal over here, and I
Yes,
call
if
that
you're
a
me.
Bluetooth round.
Bluetooth round. There we go. No, that means it's electrically connected somehow back to here.
Tell me those pieces of metal. Don't
There is
the wooden
electrical.
table?
What things are not electrical?
Wood.
Wood, yeah.
Glass.
Glass. Okay, I did have a student one time did their motor project, and they literally taped the wires down to the wood table. So, as the return path.
If you put enough current through it, wouldn't it be?
What's that?
If you put enough current through it, it would be a return.
Enough for
path.
the. No. All
He's
right.
cranking up. He's cranking up.
Okay.
Yeah, how did those power supplies
Make it work, goddammit.
Okay, some of you are still still struggling with a relay. When I was a kid, a young man, I had a four-wheel drive truck, and I wanted to put very bright lights on it. And this is back before we had LEDs. So what I did is I had my battery, and I ran that up, and I put it on a switch. There we go. And ran that all the way out, to the roll bar, and I put the light up there, and then grounded it.
How did the dash look afterwards?
And so what was my problem with this?
You put a shit ton of light on there that drew a ton.
Oh, and I didn't want just one light. I mean, I wanted like a couple of them,
Yeah, you put a
'cause
light
I'm
on
really
there.
cool.
Four-wheel
Switch,
drive along
yeah.
the AC switch, you gave us a clue.
Yeah.
The switch can't handle that much.
Yeah. So how impressed was I with the brightness of my lights?
Not
Not
very.
very impressed,
Not very. Why wasn't I not impressed?
because the switch can't handle that much current.
So what did my switch do?
Fused.
Pure resistor.
It got a little
Wow.
warm, and these were
Power sector.
not real bright. Why not?
Because all of the energy was being turned into heat at the switch.
All of that heat energy was all of my battery was being just turned into heat energy in my switch. It's great in the wintertime. I had a little auxiliary heater right there. Couldn't see shit outside. So somebody said, well, you should install a relay.
What's that?
All right. Well, what's that? I don't know. Okay. So let's look into that. And so battery. So they said, well, if you're going to do this, then you have to run really big wire, because these lights use a lot of electricity, and having a very small wire, what affects the resistance of a wire? There's four things: the
Temperature.
Diameter.
cross section, length, temperature, material. Well, all right. So all right. So I bought some bigger wire, but same switch. And did that help me out at all?
No.
No. Not only that, because how about if I just that looks good. So what two mistakes I have going on there?
Ground wires.
Oh, it's just a ground wire. What, it's to keep me from getting shocked? No, all of the power is literally coming in this way through a teeny tiny wire, then going through this, then through a nice big old fat wire, then back to teeny tiny little switch. Okay, did anything change? Nothing. Nothing changed. Where's gas mileage now? It's a big old fat wire. So
You could flip the switch and you'll just never open it again.
yeah, once the switch was welded closed. All right, so says, well, run a relay. Well, what's a relay? Well, it's okay. So now to do this, you had to run that big old fat cable from the battery up in the front, through the firewall, up into the behind the not instrument panel. It's the dashboard. Forgot what you call it on a car. So all right, so I can now I don't want to do that. So reroute the whole thing. So I run a wire from the battery. Actually, I don't even have to run it from the battery. I just take it from the fuse panel right inside somewhere, take it off the clock or whatever you've got inside, because it's a teeny tiny little wire, and I'm going to run it through a teeny tiny little switch, and that teeny tiny little switch is going to come up and go to a teeny tiny little coil that I'm just going to ground out. And this is teeny tiny little wire because none of this takes very much power at all. And I better talk fast. So, do you want me to finish this tomorrow? I'm sorry, I lost track of time. Well, I got a minute. So, now, what I can do is take my fat wire off the battery, run it under the truck, under the cab, come out the back of the bed, go through here, and then go to my light, or all of my lights. Oh yeah, with a nice big ground wire. There. And so when I turn on the teeny tiny little switch with the teeny tiny little wire, it creates a magnetic field that takes this bar and drops it down across here. And now look at that light. Comes big fat wire with no resistance, no switching issues, and this thing is super bright. That is what a relay does.
Pissing off everybody on the road.
Yes.
Oh, well.
Relay real quick.